Hey guys, Mr. Janowski here. This is the third part of the Chapter 35 slide videos. In the first part, we learned basic series and parallel circuits. In the next part, we learned slightly more complicated series and parallel circuits. And in this part, we're going to get even a little bit more sophisticated. So let's get started. So if you look at these two circuits, try to figure out what will the equivalent resistance of these guys be. So if you want to actually try that with your calculator, just pause the video because I don't want to let this video get too long. So if you want to try it, pause the video. But here I'm going to give you the answers. So the circuit on the left, the equivalent resistance of this guy is actually 0 ohms. And the one on the right, the equivalent resistance of that is infinity ohms. So that might be surprising. I remember it was surprising the first time you guys saw this. So let's see why that is. So if you're looking at that first circuit, it seems like we have a bunch of 40 ohm resistors in parallel, but the problem is at the very end, the part I've circled up here in red, you just have a wire. So essentially you have 4 40 ohm resistors in parallel with a resistor of 0 resistance because the wire ideally has 0 resistance. A real wire has a tiny resistance, but when you're doing circuits, you often pretend that they have 0 resistance. So what does that mean? If you plug that into the formula for equivalent resistance of parallel resistors, the math works out so that the equivalent resistance of this whole thing is actually 0 ohms. So when you have different branches like this, you're giving the current the chance to flow through all of the branches. So normally it would flow through all of the branches to some degree, but that's not true in this case because we've got a short. So in this case, if you hook this up, what would happen is all of the current would just take all of this path right here. It would all go through this. None of it would go through R1, R2, R3, or R4. So what would the current leaving this battery be? We can calculate that with Ohm's law. So V equals IR, that means I equals V over R. So you end up with something divided by 0, which a math teacher will tell you you're not actually allowed to do. But in physics, we say just go ahead and do it, and the answer ends up being infinity amps. So will you actually get infinity amps flowing through this circuit? No, you will not. For a couple of reasons. One is that the wire is not actually going to have 0 resistance. It'll have a very small resistance. But the other thing that's going to happen is as soon as the current starts flowing through there, you're going to get a very, very big current, and big currents create a lot of heat, and then something is going to melt or catch fire. So you're trying to avoid making shorts when you're building a circuit because you don't want to catch fire. Fire bad. So if you have a circuit like this is another example of a short. You're not really in risk, in any danger of something catching fire, but you've basically made R2 useless. You may have been trying to build these guys in series or some other way. So what the current's going to do is come up here, flow through R1. That's going to keep the current kind of manageable. It's not going to jump up to a very high number. But instead of going through R2 and this way, it sees this path of no resistance. So it's going to come through here, all come down here, and go through there. So we would say that R2 has been shorted out. So the other circuit, what's wrong with this? This looks like 2 resistors. Are they trying to be in series? Are they trying to be in parallel? The problem is there's no connection. From here. You haven't given the current a complete circuit to flow through. You have an open. So if I just make that connection, is that better? No, that's actually not any better. Because if you look carefully, you've just made a short. So current would leave here, come here, skip these 2 guys completely, and just go down here and through here. You'd have a voltage across a very small resistance. You would get a fire. So how would you fix it? 2 ways to fix it. One is you could disconnect it here and connect that over to here. That would give you these 2 guys in series. But maybe you were trying to build them in parallel. In that case, you would add, like this picture shows, you would add another wire from here over to here. So depends what you wanted to do with those resistors. So here real quick, the definitions of shorts and opens. You have a short if you've got a circuit that allows current to flow through an unintended path with zero resistance. You have an open when you haven't actually completed the circuit. You've got an electrical circuit that lacks a complete path through which the current can flow. So then moving on to analyzing circuits. I'm not going to go into analyzing circuits in this particular video because I've made several videos about this. So some way back when we made the chapter. I've also made videos for the study guide. So those are up there on Google Classroom. So make sure you know how to do analyzing circuits. This is where you're going to figure out, well, what's the voltage across each resistor? What's the current through each resistor? How much power is it using? All that stuff. And again, I like comparing this to Sudoku because you're going to start, it's kind of like a game. You're going to start with a few clues, and then you use those clues to find more clues. And then you use all the clues together to figure out everything. So yeah, watch these videos. Watch the other one I put up from the study guide problem. That's on Google Classroom. So quick review. What is a short? And what is the equivalent resistance of a short? A short is when you've created an unintended path for current to flow that has no resistance. So in this case, this guy is a short, and the equivalent resistance of a short is 0 ohms. And what is an open? And what is the equivalent resistance of an open? An open is when you haven't given the current a full path to flow through. So essentially, in this circuit here, this would be your open. The equivalent resistance of this is infinite. So hopefully that helps.